We have about 15 participants. We're still waiting for about 10 participants to join in.
Okay, so all together 25, yeah? Okay.
Doctor, we're supposed to have 28 students.
Okay, all right.
So for participants, perhaps you can try to invite and inform your friend to join this WebEx session with Dr. Zamir so that we can start our session for today.
Normally, normally for the technical talk, do they have to turn on their videos or they don't have to?
Because we would like to reduce the internet.
The data, okay, no worries. Okay.
So they just
Okay.
have to turn off and
Okay.
But in case kalau perhaps doctor would like them to actually turn on their video and our camera, then doctor just let them know lah.
Okay, no problem.
But one student at one time to turn on their video.
Okay, all right.
So doctor, I will be the moderator for the session. So
okay.
If they have a question, ask them to write a question in the chat room.
Okay.
So then I will read it through to doctor lah after that.
Okay, no worries.
Alright, okay. So for the participants, you can actually write a question to Dr. Zamir at the chat room and see there is a chat room available dekat bawah tu, and just write any question there, then akak akan bacakan kepada Dr. Zamir. Dr. Suri, you have to stop the session at 11, is it? Ataupun boleh extend?
Yeah, okay then. Okay, all right.
Okay. So perhaps we already have 17 participants right now of 20 participants.
All right.
So I guess we need to start the session because it's already 10:06 a.m. So with that, Doctor, and Assalamualaikum and good morning to Dr. Zamir and to dear participants. So basically, we will start with our technical workshop for today with the science track with Dr. Muhammad Zamir from School of Physics, University Science Malaysia, made his talk on solar energy. So with that, Doctor, the floor is yours.
Okay, thank you, Ms. Putri Sima. So, Assalamualaikum, good morning to all. Apa khabar semua, sihat? So you can use the chat box all the time to write down anything. If you have questions. Okay, Alhamdulillah. So I've seen in the list that you are Form 3, Form 4 students, right? Betul, eh? Okay. So how are you going so far in this youth industry bootcamp, E-Bootcamp? So how's it going? Very good. Could you please turn off your mic?
Sorry,
Okay,
dear
just fine.
participants, please turn off your mic. Please mute so that we can hear Dr. Zamir voice clearly. So again,
Right. So okay. Have you guys learned a lot already? Still excited to learn new things from this e-bootcamp? All right, that's good. Okay, I'm Zamir, Muhammad Zamir bin Pakhuruddin from School of Physics, USM, which is Science Malaysia. So I've been with USM for 3.5 years since end of 2016. Before that, I was in industry for about 8 years. So I was in Siltera, Malaysia, Kulim High Tech Park, and also with Fuji Electric, also in Kulim High Tech Park, doing semiconductor, wafer fabrication, thin film industries, integrated chips fabrication, and hard disk drive fabrication as well. So then I joined USM School of Physics back in 2016. Right after completing my PhD in photovoltaics engineering or PV engineering. So today I'm going to share with you some knowledge on solar energy. Okay, some knowledge on solar energy. So let me walk you through the technical talk. So as we know, we've been talking about solar energy for quite some time, especially in Malaysia. What we call the direction of the country is getting clearer towards adopting more and more renewable energies into our energy system. So you can see from this picture, you can see solar panels, you can see wind turbine. What else are the other sources of renewable energies that we know so far? Apa lagi sources of renewable energy that you have learned so far? You can see only solar panels for solar energy, wind. What else? We also have biomass. Yeah, wave energy. That's good. We also have biomass. We also have geothermal. Do you know what powers our country all this while? Where do we get all the energies from? We've been talking about what we call TNB grid, right? TNB grid. TNB grids. We've been using coal and natural gas, hydro. Yeah, hydro for renewable energy as well. So there are many sources of renewable energies. So in this talk, I'm going to focus just on one, which is solar energy. So I've seen some of you already answered these questions. Maybe you would like to write it down in the chat box as well. Why do you think we have to adopt solar energy? Just put it down. It's okay. We can have a look at it, and then we can discuss a little bit later. Why do you think we have to use solar energy? Because we get a lot of sunlight. Brilliant. Yes, we have a lot of sunlight throughout the day. Can gain all the time. It will not finish. Exactly, it will not finish. Bila solar energy akan finish? When are we going to get out of the sun? It's going to be there forever, right? Of course, not at night, but when it's going to be obsolete, it's going to be here forever, isn't it? To produce electricity, great. What else? Why solar energy? Those are pretty much the obvious reasons that we should start embracing solar energy. Renewable energy some more. Yeah, renewable energies, right? You can always have it. So let's go to the second question. Kurangkan minyak, yeah, that's good too. Kurangkan minyak, so that will cause a pollution to our atmosphere. All right, let's move on to the second question. You'll get to see all these informations and this knowledge along the way throughout the talk. How do we convert solar energy into electrical energy? What do you know? How do you convert solar energy into electrical energy? Macam mana nak tukarkan dia? From your sun outside using solar panel. Yes, using solar panel. We're going to learn on what's the operation of solar panel that makes the conversion possible. Okay. How about question 3? What material do we use in solar cells or solar panels? What do we use? Kita dah nampak solar panel atau bumbung kan? Apa yang ada dalam tu? Apa material yang kita guna dalam tu? Maybe no idea so far? Yeah, silicon, that's great. So we're going to learn about where is the source of silicon, okay? Right, move on to the next one. How to calculate conversion efficiency of the solar cells. This one is a little bit technical. I'll walk you through the curve and see and show you how to exactly calculate the conversion efficiency. And finally, before I start the talk, what are the applications of solar cells? Of course, on our rooftop for residential application. Where else have you seen? Where else can we use the solar cells or solar panels, if you like? PV station, satellite, great, brilliant. What else? PV station for a huge one. If you're talking about a power station, high energy applications, windows, satellite, Hubble telescope. Wow, you know a lot, yeah? Solar car. All right then, so let's move on. So basically you've got some preliminary knowledge on the solar technology and solar energy. So let's move on to the talk. So do you know that every hour the sun beams down more energy than the world uses in a year? So every single hour from 9 a.m. to 10 a.m. today, we've been receiving more energy than the world needs to use in 1 year. So that's like, if you Google up, then you can see the figure 430 quintillions of energy, and that's about 430 times 18 of zeros after 430. So that is the amount of energy that we receive just in a single hour. And based on the record by Department of Energy of US, so they summarize that the energy consumption of entire world population in 1 year is about 410 quintillions of energy, and that's about 1018 as well after the figure. So that means whatever we receive in a single hour is already a lot. Can cover what we need to use in 1 year. It's just a matter of harvesting. It's a matter of conversion efficiency. It's a matter of what technology do we use and what's the best for now. All right, so some of you have answered that to be able to convert the light into electricity or electrical energy, we need to use solar panel, right? For your information, the solar panel or equal to solar cell, we also call it as a PV cell or PV panel, and PV stands for photovoltaic. So what is this photovoltaic? So light into electricity conversion by a semiconductor material by a photovoltaic effect. So this is the very process that we need to use in order to convert the sunlight from the sun or from other sources of light into electrical energy. So it's called photovoltaic effect or PV effect. So why is it called photovoltaic? So it's called photovoltaic because you can actually split the word into two parts. The first is photo. Photo means light. Why photo means light? Because if you learn about light in detail, you're going to learn that light is actually made up of packets of energy called photons. So you cut it down to photo, then you plus with voltaic, which means upon illumination of a semiconductor material to the light, then we're going to generate voltage across a device, which we call solar cells. So therefore, we call this effect as photovoltaic effect. Light-induced voltage generation across a device, okay? So that's why we call it photovoltaic effect or PV effect. So why solar energy? So we have abundance of sunlight, especially in Malaysia. We have a lot of sunlight. Kita tak ada four season punya nature kan. We have either it's hot or it's raining, right? It's never too cold or it's never extremely hot. So it's between 27, 28, perhaps up to 33, 34, 35. Kalau panas sangat, perhaps 36. But we hardly exceed 40 degrees. So we have abundance of sunlight, daytime, and that's already enough to generate sufficient energy to power out houses, residential areas, industrial areas, commercial buildings, and other stuff. So second reason is that solar PV is a clean energy source. It doesn't produce any emission of any kind. There's no CO2 emission to the atmosphere, no greenhouse gases. So therefore, we can reduce the ozone depletion, right? And the final reason is that over the years, I'm going to show you later on. Over the years, we keep having increasing efficiency of the solar cells. So if you talk about solar panels, kalau you nak tahu dia punya what you call the benchmark, whether the technology is feasible or not to be adopted by population, it is benchmarked as technology cost. So we call it technology cost, which is calculated based on USD per watt, right? USD per watt. Why USD per watt? Because we need to know how much cost do we need to spend to be able to fabricate the solar cells and solar panels, and eventually how much power in terms of watt can we extract from the solar cells or the solar panels. So therefore it's benchmarked as technology cost as USD per watt. So the current benchmark for the USD per watt now, as of 2020, is somewhere around less than USD 25 cent per watt. And this is already cheap. So I'll show you how, I'll show you why. So this is our solar spectrum, all right? This is our solar spectrum. Let me move this one a little bit to the right. So setiap hari kita tengok solar spectrum kan, kita tengok sunlight, tapi kita tak pernah terfikir on the solar spectrum, right? So if you look at the sunlight, we have three portions of what we call three main portions. The first portion is UV region, which is if you can see on the right figure, it's somewhere around 200 to 400 nanometers, right? That's called UV region. This is what we don't want for our skin. So kadang-kadang kita pakai cream and so on, right? So also thank God we have a lot of cloud in Malaysia. So cloud ni dia akan scatter some of the incoming UV radiation somewhere else. So therefore this UV radiation will not hit your skin as much. In comparison, if you compare to countries like Australia yang tak ada banyak cloud, tak ada banyak awan, so dia punya UV radiation is a lot higher. So therefore the skin cancer in Australia is a lot more if you compare to our country, for example. So that's UV. You don't want the UV for your skin, but you want the UV for solar cells. Right, so the central portion of this graph is called visible region. So visible region ni portion yang kita boleh tengok, light yang kita boleh tengok, cahaya nampak. So that's about 400 to 700, 780 or 800 more or less in the spectrum. So we can see all these colors from violet, blue, green, yellow, red, orange, red, and so on, right? And the last portion on the rightmost, if you see on the graph, beyond 800, above 800 nanometer, is called infrared region. Infrared ni kita tak nampak, tapi dia ada. So we can feel the heat, but you cannot see the light, right? But it's there. So this is the whole spectrum of the sunlight. So if you're talking about photovoltaic technology or solar panel or solar cell, theoretically or ideally, you want to harvest everything from the sun. You want to harvest UV, you want to harvest visible, and you want to harvest infrared as well. Okay? Okay, material for solar cell. Any guess? What do you think we use in the solar cell? Some of you said silicon. Ada lagi material yang kita pakai for solar cell? What else do you know? Material for solar cells. Ada semua silicon No other materials? Yeah. Material for solar cells, material for solar panels that we use now is actually equal to the material that you use in your integrated circuit. Integrated circuit ni kita nak nampak kat mana? Where can you see integrated circuit? Do you use any integrated circuit now? Do you have integrated circuit now with you? Integrated circuit ni apa? Yes. Where is it, Rakesh? Where do you use the integrated circuit with you now, Rakesh? Laptop, exactly. Good. So integrated circuit ni apa? Integrated circuit ni is actually chips. Chip yang you tengok tu yang belah kiri tu, kiri 990, this one is used by Huawei, right? It's the chip that you use in your laptops, in your phones, in your cameras, in your tabs, in your gadgets, consumer devices. So material yang kita pakai dalam solar cell, solar panel, exactly the same like material they use for your integrated circuit or chips. So it is made of silicon, right? Made of silicon. Apa silicon ni? What is silicon? So silicon ni kita dapat dari mana? Where do we get the silicon? We get the silicon from the sand. Yes, good. We get the silicon from the sand. Good, Sohail. So kenapa kita dapat silicon from the sand? What is sand actually? Sand is actually silicon dioxide, SiO2, right? SiO2. So maknanya banyak kalau kat Penang ni, if you go over to Teluk Bahang, Peringgi, so it's a lot of sand, right? Kalau you pergi ke central region dalam dunia ni, dekat Arab sana, dekat Gurun Sahara lagi banyak sand. So Saudi sana banyak sand. So they are blessed with lots of sand. So actually they can manufacture a lot of chips and solar cells. So sand is essentially silicon dioxide, SiO2. So to be able to get silicon from the sand, we need to reduce silicon dioxide to silicon. So that means ada belajar redox reaction ke sekarang? Have you learned about redox reaction? Reduction and oxidation process? Ada belajar so far? Ada belajar. Okay, that's good. So talking about SiO2, you have to reduce the SiO2 into silicon. So that means you need to remove the oxygen from the SiO2 to be able to get silicon. So not only that reduction process, bila you dah dapat silicon tu, you then need to refine the silicon to be with 6N purity. 6N purity maksudnya 6N means 6N, saya tulis ni. You can see the writing, right? Can you see the scribbles? Okay, good. 6N purity means 99.9999%. Then only you can use the silicon for solar cells. That means the silicon has to be pure. So to be able to be a pure silicon for solar cells, the silicon has to be purified through a few processes. Nanti you akan belajar ni di peringkat universiti lah. So there are a couple processes that need to be done in order to purify silicon to be able to use as a solar cell or solar panel. Kalau you talking about integrated chips or integrated circuits or chips, it's even worse. It's even worse in the sense that you need to purify it even more. Kalau you nak pakai chip, you have to purify the silicon up to 9N. Baru dia boleh jadi integrated circuit. Kalau you guna 6N for silicon, then it won't work as your transistor to be as your integrated circuit. So you need to make a 9N chip. That means 99.999999% purity. Then only it could work as a transistor in your chip, right? So for solar cells, so it only requires 6N. So the moment you have this silicon chunks, we call it macam batu-batu tu, it has to go through few processes to be able to produce an ingot. Ingot ni macam bantal peluk. If you have seen ingot before, dia macam bantal peluk yang kita buat tidur tu. Then the ingot has to be sliced. Kena potong nipis-nipis macam dipotong bawang tu, then it will produce these silicon wafers. So the typical thickness of the silicon wafers now in the industry is about 180 micron, 200 micron. So do you know how thick is your hair? Who knows how thick is your hair? Tolong off mic siapa yang on tu. Who knows how thick is your hair? Any ideas? Tak ada idea? 0.1 mm? Yeah. 100 micron, right? 100 micron is 0.1. Yes, that's about it. Yes, that's about it. So it's about 100. If you're talking about your hair, so your hair thickness is about 100 micron, more or less. Ada yang rambut tebal, ada yang rambut nipis, but more or less it's about 100 micron. So the silicon wafer thickness here, the thickness, if you look at the cross section here, so that's about twice of our hair thickness. That's about 180 micron thick. Okay, so that's the silicon wafer. So if you look at the history, so the first silicon solar cell was invented back in 1954. So that was long time ago. In Bell Laboratory in the US. So the first silicon solar cell was fabricated with 6% efficiency by these three scientists named Person, Chapin, and Fuller in Bell Labs, right? So it was only 6% back then, and now the world record is up to 27% for the single PN junction technology. So back then they didn't even know what to call it. So they even call it solar battery. Oh, sorry. They even call it solar battery. While actually, if you look at the solar cell or solar panel, technically it's not a battery because it doesn't do any storage, but it only helps to convert the sunlight into electricity. So therefore, it's not a battery. But back then they didn't know what to call it just yet. All right. So it started back in 1954. So if you look at now, 2020, as the silicon technology, silicon solar cells, silicon solar panels dominates about 90% of the PV market. So with 20 to 25% efficiency. So if you look at the trajectory of the conversion efficiency back in 1954 until now, so it only grows like from 6% in 1950s to about 27% in 2020. So that's quite a slow trajectory, right? But if you look at the physics of it, the theoretical efficiency that it could ever reach is only around 29% if you use a single PN junction. Maksudnya kalau you combine satu semiconductor silicon yang ada P-type, maksudnya you ada banyak lohong ataupun hole, then you combine dengan satu lagi yang ada N-type yang banyak elektron. So you jadikan dia satu PN junction, simpang PN. So the theoretical limit of this one pair of junction is only up to 29%. So to be able to increase the efficiency more and more, you need to put more junctions onto each other. So you need to have more than one junction. That means you're going to have satu simpang PN, satu PN junction, then another PN on the beneath one, and another one, and another one. It could go up to 6, 7, but it's going to add the cost at the expense of the conversion efficiency. So there, you have to come back to technology cost, whether or not it's going to be affordable to be adopted by the population. Okay. So this is how a solar cell looks like. Bila you tengok solar panel yang besar tu, is actually composed of 60 cells, 60 of this. Usually is about, it's about 60. Some panels have 72, some even have 96, right, of this single cell. So they are all what we call arranged in series, but some strings they have a parallel connection as well. But generally, the panel is made up of a couple of cells, right? So if you want to know what's going on in the cell, this is how it looks like as a schematic representation. So it is composed of a wafer, usually P-type. It can also be N-type. Maksudnya dia punya carrier yang ada dalam tu is either a hole or electrons or lohong atau electron. Then you need to sandwich with another layer of opposite polarity, negative. Kalau tadi hole atau lohong tu positive, so electron is negative. So then you have a PN junction. Then kita kena ada electrode dekat atas, and this negative contacts. Then you need to have a positive electrode at the back. Then you're going to have a basic solar cell, right? A basic solar cell. So it's composed of a single PN junction of a semiconductor material, and then you need to have a contact on the front, contact at the back to be able to extract your electron hole pass generated by the sunlight. Okay, just now I told you that silicon dominates more than 90% of the market. then what about the remaining 10%? So the remaining 10% is dominated by some other technologies called thin film technologies. So ataupun teknologi yang berasaskan filem nipis. Kalau you tengok wafer tadi, it's 180 micron thick and it's rigid in nature. Dia rigid lah, dia keras, tak boleh bend. And some other technologies is called thin film technologies or thin film solar cells, which are made of the first one on the left is CIGS or copper, indium, gallium selenide. So you're actually combining more than one element to make a solar cell. So kalau macam silicon tadi kita guna satu element, just a silicon to make the solar cell. But this solar cell combines 4 different elements to make a solar cell. So that's called CIGS, or some people even call it 6 solar cell. Copper, indium, gallium selenide. Okay. The second one in the center is called polymer solar cell, or it's also called organic solar cell. Right, it's made of polymer, so maksudnya you tak perlu pakai inorganic material macam silicon, macam CIGS, but you can also use polymer based material. Right, you can use dye, you can combine with some other polymeric based materials, and the beauty of this technology is that it can be roll to roll printed, macam saya tunjuk dekat slide ni. Dia macam you gulung je, gulung macam kain elar tu, kain elar dekat Nagoya ke whatever kan. You gulung, then you can actually roll and print using inkjet printing technology.
Guys, kejap rasanya Dr. Zamir is being disconnected.